Good morning, class. Okay, today we will continue with our chapter 7 notes. And today, hopefully, we'll finish these notes and go to chapter 8, which is going to be our first, should I say, larger topic to say, because the other one is going to be built on chapter 8. So, do you have any question on chapter 7? Anything that you want to clarify that we've done so far? Chapter 7 is our first branch of statistics about inferential statistics, where we are trying to make inference about a population parameter, say the population mean and the population proportion. So we talked about two types of estimations, and one is the point estimation, which is a single numerical estimate of a population parameter. And we talked about some of the point estimates for population mean, which are the sample mean, sample median, the mode, and the mid-range. And we talked about one that is the best point estimate for the population mean as the sample mean. And how do we know that is the best point estimate? We said we looked at some of the properties of a good estimator, which includes being unbiased, which means the expectation of your estimator, which is the sample mean, is equal to the population mean. And we said it should be relatively efficient, which means that as you increase your sample size, that estimator should approach your population parameter. And we said it should be consistent. Consistent means that, the consistency is where we say when we increase the sample size, the estimator approaches the population parameter. And relatively efficiency is where we say that among all estimators for that parameter, for instance, for the population mean, we have the sample mean, sample median, the mode, mid-range. They are all estimators for the population mean, right? But the sample mean has the smallest variance. So that is the one we said it is relatively efficient. Okay, so these are just review on estimation. Now we said that, okay, having a point estimate alone is not enough because it is not always possible or easy to estimate the population parameter efficiently. It is not possible for you or not easy to get the sample mean to be equal to the population mean. So how do we go about this? We said, okay, instead of worrying about finding a point estimate, how about we construct a confidence interval around our point estimate with some degrees of certainty or degrees of freedom? And with a confidence interval, we can say with some degrees of freedom or certainty that, okay, we believe that our population estimate or parameter should be within this interval. And that is what leads us to interval estimation. And we looked at how to construct a confidence interval for the population mean. Now, what we are about to do is to construct the confidence interval for the population proportion. So in this class, we only worry about two estimates: population mean, population proportion. Now, before that, I gave this illustration to serve as a guide such that if you are constructing a confidence interval for the population mean, then you ask yourself, there are two scenarios. One is when you know the population standard deviation. When you know the population standard deviation, we will always be using the z-score critical value in our formula. And since we know the population standard deviation, we leave that in the formula. However, if the population standard deviation sigma is unknown, then you replace your Z score critical value with T score critical value. And you replace your sigma, which is unknown, with the sample standard deviation. Any question on this so far? Okay, so now we move on to our next and last aspect of confidence interval, which is the confidence interval for proportions. So what is proportion? Proportion is just a percentage or a fraction of an entity, right? If I ask, what proportion of students in this class are sophomores? What am I interested in? I want to know, out of all the students in this class, what percentage or how many are sophomores? So if you want to do that, what do? You count how many students you have in the class. If there are 10 students, then you count how many students that are sophomores, and you take the number of sophomores divided by the number of students in the class. So that is basically what proportion is. I may also want to know what percentage of students in OSU drives to school. And in that, my sample size will be all the students in OSU. That is the population. And now the proportion of or the subset of interest will be those who drive to school. And now if I know that 68 of them drive to school and there are 100 students in OSU, then that proportion becomes 68 out of 100. And I can change it to percentage by multiplying by 100 to get 68% or 0.68%, 0.68, sorry. So that is what proportion is all about. And now, so we also have our point estimate for the proportion, which is going to be the sample proportion, because it may not be possible for you to ask every student in OSU to find out how many of them drive to school. And so you rely on maybe the students in your class, that is your sample. Then you ask how many of you drive to school, then you get probably 10 students out of 20, and you use that to find your sample proportion. So that is the sample proportion that is estimating the population proportion. Now, we still do not want to use the single point estimate because it is always not going to be exactly the same. And what is the difference between a point estimate and the population parameter? What do we call that? Who remembers what we call that? The difference between an estimator and the population parameter, that is the margin of error, right? The margin of error is the maximum likely difference between a point estimate and the population parameter. So because of this difference, we will want to construct a confidence interval around our proportion or our sample proportion. And we will say, okay, we are 95% confident that the population proportion will fall within that particular confidence interval. So a little bit of notation here. So we will always denote our population proportion with capital P. And the sample proportion, or sorry, just P. And the sample proportion will always be denoted by P hat. And this P hat will always calculate it by taking X divided by N. X here is the number of samples that possesses the characteristics of interest. In the example I gave about the number of students who drive or the proportion of students who drive to school, then those who drive to school will be our subset of interest, right? And that will be X. And the total number of students in OSU will be N. Does that make sense? Okay, so proportion isn't very challenging and I think it's just straightforward. So we want to just change slightly the example we saw above and say, if I take a random sample of 150 OSU students and find that 98 of them said they own a car, then the sample proportion of students that own a car is, what would that be? Anyone? Great. 89 divided by 150. So our sample proportion which is x divided by n. Our x is 89 and our n is 150. So if you solve this one, you can also change this to fractions or decimals. You get 0.5933. So if I ask, what is the proportion of students who do not own a car? How will you find this? Okay. So yes, you can multiply this one by 100 to get a percent, right? That would be 59.33%. Yes, those who do not own a car. Yes. Great. So to get a proportion of students that do not own a car, you simply just take 1 minus this. So that leads us to 1 minus p hat, which is 1 minus 0.5933, and that will be 0.4067. Great. So with this, we are good to construct the confidence interval for our population proportion. So if we want to do that, this is the formula, and it is very easy, I guess, because you can compress this formula to just one. This is the same as p hat plus or minus z alpha on 2 p hat 1 minus p hat divided by n. So this is the same thing. So this is the compact form. So all we need to do is find our sample proportion and find our critical value, z critical value. Yes.
So 1 minus p also q?
Exactly. So 1 minus p, so some textbooks or some people, some professors use 1 minus q. I think I use 1 minus q in some of my notes, but not in this one. Yes. Good question. So instead of taking p hat times 1 minus q, 1 minus p hat, you can just say p hat, q hat, right? That's the same thing. I prepared this one because I don't want to be dealing with two different like notations. Just deal with only p. So the reason why we are using the z-score critical value here is because if you remember, is it chapter 5 when we did the binomial distribution? So the binomial distribution uses proportion, and we said that that binomial distribution can be approximated by a normal distribution. So p hat here, which is the proportion, is approximately normally distributed with this mean p and standard deviation given by this. So this is always our standard deviation. Now, you can tell me what this is. What is this one? We saw this when we're doing for population mean. This is the margin of error. We're going to use that when we are calculating the sample size. So as usual, we also have some assumptions that we need to check before we can use this formula. And the first assumption is that we have a random sample. And the next example is that if you multiply the p hat, that's the sample proportion, by the sample size, it should be at least 5. And the same applies when you take n times 1 minus p hat. So these two assumptions need to be satisfied and the conditions for binomial experiment are satisfied. Well, I'm not going to be asking you these questions in exams, but it's just good you get familiar yourself with them. In case you're working on your own research, you take note of those. So let's take our first example, unless you have a question. So the first example says that, okay, let me just repeat what we are doing. So we are working on the proportion, and we said that we will construct the point estimate, which is the sample proportion, and that is not enough. We want to construct a confidence interval for the population proportion. And to do that, we need to know our point estimate, which is p hat, which is sample proportion, which is usually equal to x divided by n. X here is the subset of interest. For instance, if you want to find out the proportion of students who drive to school in OSU, you will want to know how many students are in OSU, and that will be n, and how many of them drive to school, then that will be your x. And then you divide that to get your p hat. And with p hat, everything is known except this guy, which we know how to find, right? So now we are going to do our first example. And the first example says, a survey of 1,400, that is 1,400 randomly selected students found that 325 of them paid for their education with students' loans. Find the 90% confidence interval of the proportion of students who paid for their education with students' loan. And how do we interpret this interval? So I just brought down the formula here, but if in exams, you have to keep this in your formula sheet so that you can use it. Okay, so this is a formula, and in the problem, we have 1,400. What is this 1,400? In terms of notation? N, that is right. So this is N, the sample size. How about 325? What is that? Anyone? X, great. And so with this, we can find our p hat. P hat is x divided by n. So we know x to be 325, which means our p hat is equal to 0.23. So confidence interval, we need to find our z alpha on 2. How do we find z alpha on 2? We are finding a 90% confidence interval, which means that our alpha is going to be 10, or 10% or 0.1 divided by 2, we get 0.05. So we go to our z table to look for this critical value. So looking for 0.05. 0.05 is between this and this. So you can choose either of them. So if you do that, if I'm choosing the first one, I'll get 1.64. So Z is 1.64. So I have everything I need. I just put them into the formula. So I have 0.23 minus 1.64 into brackets 0.23, 1 minus 0.23 divided by n, which is 1,400, less than p less than 0.23 plus 1.64, 0.23, 1 minus 0.23 divided by 1,400. So if you solve this one, you get 0.23 minus 0.018558 less than p less than 0.23 plus 0.018558. So this will end up being 0.2114 less than p less than 0.2486. So you can put this in your bracket form, 0.2114, 0.2486. So okay, so who wants to interpret this confidence interval for us using what we have in the problem? Yes.
You're 98% confident that between 21.4 and 24.9% of students paid with student loans.
Exactly. So we are 90% confident that the proportion or the true proportion of students who paid for their education with students' loan is between 0.21 and 0.24 or 0.25. So let me write it. We are 90% confident that the true proportion of students who paid for their education with students' loan is between 0.21 and 0.25. Any question? So these are things that you may encounter in your own research. Let's say you are doing your final capstone project and then you decided to probably do a research on food. Could be food quality, could be preference of football or anything, right? just think of anything you are interested in and you want to know whether people like it that much or not. If it's about food preferences, right? You decide to find out what proportion of OSU students eat from the student union. Then you decide to conduct your research by taking a proportion of students and ask them how many of them take their lunch from the student union. Then you get that proportion. Then you want to construct the confidence interval around that point estimate and you interpret, okay, you say if you're using 95% confidence, say, oh, we are 95% confident that about the proportion or the true proportion of students who eat from student union is between 0.65 and 0.95. So that's just all we are doing. It's not just for nothing. It's for you to learn how to do your own research using these ideas. Okay, so if no question, we move on to, again, the sample size estimation for population proportion. If, let's say, the example I just gave, the scenario you are conducting such a research, how do you know how many people to interview to be within a certain margin of error and with a certain confidence interval? So similar approach, we are going to be using our margin of error formula, and we use that to solve for n. And if you want to know how I got this n formula here, I can again prove it for you, but at your level, it's not required to learn the proof. But I got this simply using this formula that I circled here. Okay. Let me see if you have time. So if you have time, I can show you how, but you don't have to prove this. Or yes, I have your exams papers here, exams 2. In case you did not pick it, I'll give it to you before the class ends. So from the confidence interval formula for population proportion, we have it something like this. P hat minus P hat divided by n. And this is the guy we are interested in, right? So, and this is what we call the margin of error. And we usually use the margin of error to find for our sample. So with this, I will solve for, this is E, margin of error is E, right? Z alpha on 2, P hat, and minus P hat divided by n. I want to solve for n, so I'll divide this one by P alpha on 2 equal to P hat and minus P hat divided by n. How do I get rid of square root? I'll square both sides. So if I do that, this will cancel this. So I'm left with E Z alpha on 2 all squared equal to P hat 1 minus P hat divided by n. So I'll solve for n, and that will give me n will be to have n E divided by Z alpha on 2 all squared is equal to P hat 1 minus P hat. And I want to solve for n, means n will be equal to, bring this one here, have P hat 1 minus P hat. Now I have, so once you cross multiply, the Z will come out, right? So this will come up, this will come out. So we have Z alpha on 2 P all squared. And I guess that's the formula we have. But you don't need to worry yourself how to prove this. Just learn it, have it on your formula sheet. During exams, you can just use it. So let's use this to find the sample size or the number of people to survey in our research. If we wish to find the sample size that will give us the best estimate of the population proportion, then we use the formula here. And always remember to round it up. And take note of these. There are two scenarios to consider when finding the minimum sample size needed to estimate population proportion. One, if an approximation of p hat is known, then use it. If it is unknown, then take it to be 0.5. If it is not given, then you should use 0.5. If it is given, use it. And the reason why we use 0.5 when the p hat is not given is because it is the one that will give us the largest sample size. And the reason is that there is no combination of p and p hat and 1 minus p hat that will give us any value larger than 0.25. So again, this one I don't need to prove to you here. If you want me to prove for you, I can do that, but you don't need to learn the proof at this level. So what I want you to take note is that if the p hat is given, use it. If it is not given, use 0.5. With that, we want to try an example. A researcher wishes to estimate with 95% confidence that a proportion of people who have a doctorate degree in mathematics, mathematics. A previous study shows that 8% of those interviewed has such a degree. The researcher wishes to be accurate within 2% of the true proportion. Find the minimum sample size necessary. So all we need to do here is to identify our values here. So this is 95% confidence, which means Z alpha on 2 will be, alpha is going to be 0.05 divided by 2, get 0.025. So we go to our Z table. 0.025 should be 1.96. Let me see. Say it again. So we are looking for Z from the Z table, and that's what we're doing right now. Okay, so we know alpha is 0.05. We divide by 2, we get 0.025. So we come to the Z table and look for 0.025. And that will give us 0.025 is here. So we trace here, we get 1.9. Trace here, so that will be 1.96. So now we have our Z alpha on 2 to be 1.96. How do we know P hat? A previous study shows that 8% of those interviewed has such a degree. So what is this 8%? P hat. Great. So 8% is 0.08. The researcher wishes to be accurate within 2% of the true proportion. What is this 2%? Margin of error. Great. So that is E is 0.02. So we have everything we need. So we can solve for N to be 0.08. 1 minus 0.08. Then we have 1.96 divided by 0.02 all squared. If you solve this, you should get 706.8544. What do we do to this? We round it up, right? 707. So the minimum sample size necessary for this study should be 707. Yes.
the z-squared 2.5%.
Great. So you go to the z table and look for point. Yes. Okay. So now the next one says, what if no previous study was done? Find the minimum sample size necessary to be accurate within 2% of the true proportion. So what this means is that we do not know the p-hat because there was no previous study. So if p-hat is not known, p-hat is not known, what do we do? Use p-hat equal to 0.5. That's what they said here, right? If p-hat is unknown, let p-hat equal to 0.05. So now we have our n equal to 0.5, 1 minus 0.5. We have the same 1.96 and 0.02 all squared. And that will give us 2401. So since this is already a whole number, we do not need to round it up. Okay, so we have some review. Since we have some time, we'll do some of the review. The first review problem says, a survey of 120 randomly selected families shows that 76 of them own a pet. Find a 95% confidence interval of the true proportion of families who own a pet. Interpret the confidence interval. So with this one, what do? We need to identify what 120 is and what 76 is, right? So what is 120 here? And 76 is x. So n is 120, x is 76, which means that our p-hat, which is x divided by n, is 76 divided by 120, which should be I haven't solved this one, so say it again. You got 0.63? Yes, that's great. Great. 0.63.
Why? Like, I'm asking, why was Z not negative?
Okay, so the Z, we use just the positive because of how the confidence interval formula is. Even if we use a negative, we have negative and positive here, so it's still going to be the same. So we just take the positive. Okay, so 95% confidence interval means that Z alpha on 2, we already found it here to be 1.96. So 1.96, which means our confidence interval would be, we just pull our formula here, which is p-hat minus Z alpha on 2 into brackets p-hat 1 minus p hat divided by n p hat plus z alpha on 2 p hat 1 minus p hat divided by n. So p hat is 0.63 minus 1.96 into brackets 0.63 1 minus 0.63 divided by 120 p 0.63 plus 1.96 0.63 1 minus 0.63 divided by 120. So if you solve, you get 0.63 minus 0.0863 less than p less than 0.63 plus 0.086. This should be 4. So if you solve this one, you should end up with 0.54 544 less than p less than 0.716. So I did not leave space for interpretation because of how I write, but I expect you have the interpretation or some space for the interpretation. You can write it anywhere. Who wants to interpret this one? Any volunteer? Yes.
We are 95% confident that the true portion of the index we own is between 0.54 and 0.7.
Great. So we are 95% confident that the true proportion of families who own a pet is between 0.54 and 0.72. That is great. So if you can do this in exams, that is all you need to do, right? Calculate this, interpret, and get all your points. Okay, next example. The lengths of a random sample of popular children's animated films are listed below. Estimate the true mean length of all children's animated films with 98% confidence. Assume the variable is normally distributed. And so this one is not proportion. Yes. This one. So usually the interpretation is gotten from the problem. So if you come to the problem said find a 95% confidence interval for the true proportion of families who own a pet. So we just come and say we are 95% confident that a true proportion of families who own a pet. So we usually take the words from the problem and use it as our interpretation. Does that make sense?
Say that.
Okay.
But we are not 100% confident that the true portion ends when between those two numbers.
Yes, great. So the next example, this is where most students will always think that every problem will be either a proportion. This is not proportion, this is for the sample mean. And so who can tell me what we need to do here? For this particular problem, you need to, this is a population mean problem. And so what we need to do is find our X bar, go to your formula and look for what you need to find. You need to find your X bar and you need to find your sample standard deviation, S, and you use that. So we can find our Z alpha on 2 because it said we assume it is normally distributed. So to find this, we use our calculators to calculate these values, and using calculator or Excel, you get X bar to be A2 82.83, and then S will be 8.12, Z alpha on 2. Okay, so it should be T, sorry. It should not be Z. Because we do not know the population standard deviation, we'll use T. So T alpha on 2 will be 2.718. N is, how many do we have? 12. So if you do not know how I got the T to be 2.718, this is how I got it. So we use our degrees of freedom, which is N minus 1, right? N here is 12 minus 1, 11, and 98% confidence interval. We go to our T table, which is this. For the T table, when we are looking for confidence interval, we use the first row. And so using the first row, we know 98% confidence is this column. And degrees of freedom is 11. So we trace here and we get our 2.718. Does that make sense? So if that makes sense, then we have everything we need. So we put into our formula, which is X bar minus T alpha on 2 into brackets S divided by square root of N less than mu less than X bar plus T alpha on 2 S divided by square root of N. So we replace, we get 82.83 minus 2.718 into brackets 8.12 divided by square root of 12 less than mu less than 82.83 plus 2.718 8.12 divided by square root of 12. So if you solve this one, you end up with 76.4589 less than mu less than 89.201. So this is your confidence interval. I'm sorry, I said I was going to give these papers. So if you did not get your paper, please, I'll be just by the door to give them to you. I'll see you in the afternoon. Please, I also posted some of the review problems for chapter 7, so you can have them with you when you come. We'll review those ones. The test?
Yeah, like the first and second.
Yeah, so I'm not going to do that because I want you to meet with me to explain and get partial points. So after that, we'll review the test. Yes. I'm not sure if I got your question, but did I answer it?
I think so. I mean, I was just.
You want to meet with me to discuss that?
Yes.
So I'll be in the department, so you can meet with me after this.
Okay.
Yes. So if you want to meet with me to discuss the problems you missed in exam 2 for partial points, you can come to the department. I'll be in the Slack to do that with you, or Friday during office hours.